Hello and welcome to Otten Math. In this edition of Otten Math, we're going to talk about sectors of circles. Right, I have three problems for you, all relating the sector area and arc length and the central angle of a sector. Right, so the first problem is find the radius and area of a sector of a circle with an arc length of 11 centimeters and a central angle of 2.2 radians. So we're going to use our formula for arc length. Arc length is equal to radius times the radians. We know what the arc length is. It's 11 centimeters. We know what the radians are, 2.2. So we can use that information to find the radius of the circle. Right, so 11 is equal to the radius times 2.2 radians. We end up realizing that the radius of the circle is equal to 5 centimeters. Now we're going to set up a proportion. The proportion is that the central angle of the sector of the circle over the total number of radians in the circle is equal or proportional to the sector area, the total area of the sector, divided by the total area of the circle. So central angle over total number of radians for a circle is equal to the area of the sector divided by the total area of the circle. So we're going to fill in our values. We know the central angle is 2.2 radians divided by 2 pi radians, total number of radians in a circle. We don't know what the sector area is. That's what we're trying to figure out. Total area of the circle is pi r squared, or pi times 5 squared. Solving for the sector area, 2.2 times 25 pi divided by 2 pi is equal to 27.5 centimeters squared. Right, problem number 2. A sector of a circle has a central angle of pi divided by 6 radians and an arc length of 3.5 centimeters. We want to find the area of the sector to the nearest centimeter. So again, we're going to use the formula arc length is equal to radius times the radians. We're given arc length at 3.5 centimeters. We don't know what the radius is. We know the radians are pi over 6. So we're going to divide 3.5 divided by, we're going to divide 3.5 by pi over 6 to get approximately 6.7 centimeters for the radius. Then we're going to set up our proportion. Central angle of the circle divided by 2 pi radians is equal to the sector area over the total area of the circle. We evaluate, actually simplify the ratio central angle over 2 pi, reduces to 1 over 12. The area of the circle, the total area, 6.7 squared is 44.9 times pi centimeters squared. I multiply 1/12, I divide 44.9 pi divided by 12, and I end up with 3.74 pi centimeters squared. Last problem, we're going to find the radius and arc length of a sector of a circle with sector area 25 centimeters squared and a central angle of 0.5 radians. All right, so this time we're going to start with our proportion. Central angle over total number of radians in a circle is equal to the sector area over the total area of the circle. And we're doing that because we want to find out what the radius is, and we're going to back the radius out once we find the total area of the circle. So we're given central angle at 0.5 radians. We're given the sector area at 25 centimeters squared. So we're going to fill in these values and solve for the radius. 0.5 over 2 pi is equal to 25 centimeters squared divided by pi r squared, which means that 50 pi, or 2 pi times 25, is equal to 0.5 pi r squared. I'm going to divide by 0.5 pi, both sides, and I end up with r squared is equal to 100. The radius is equal to 10. All right, so now we're going to use that information to solve for the arc length. And the arc length, again, is equal to the radius times the radians. So we have a radius that we just discovered of 10, radians of 0.5, so the arc length is 5 centimeters.